Have you ever noticed the world kinda going out of focus? You know, a street sign becomes a blur, or the words in a book just lose their sharp edge? Well, it's not just you. It's actually a simple error in physics that's happening right inside your eye. So let's get a clear picture of what's really going on. So here's the core idea, and it's kind of a mind bender. Your eyes don't actually see things. Nope. They're more like these incredible biological lenses, and their main job is to capture and bend light. It's your brain that does all the heavy lifting, the seeing. It takes that light and interprets it, creating the world you experience. And that whole process of bending light, that's called refraction. All right, so this is how it's all supposed to work in a perfect world. In an ideal eye, you've got the cornea and the lens acting like a high-tech camera. They bend the incoming light so it all meets at one single super sharp point right on the retina. And when that happens, bam, you get crystal clear vision. But what happens when that focus point is just a little off? Well, that brings us to our first really common error of refraction, myopia. And you've almost definitely heard of it by its other name, nearsightedness. This is exactly what happens when that perfect light-bending process we just talked about goes a little wrong for things that are far away. So with myopia, the physics is actually pretty straightforward. The eye is just bending the light a little too much. Now, this can happen for a couple of reasons. Either the eyeball itself is a bit too long, or the cornea is a little too curved. And the result is that the light from distant objects focuses in front of the retina instead of right on it. That's the reason why things up close, like your phone or a book, look perfectly clear, but things in the distance, well, they turn into a blurry mess. Okay, so how do you fix that? Well, the solution is surprisingly elegant. We use a concave lens. You'd know it as a minus prescription on your glasses. What this lens does is it spreads out or diverges the light rays just a tiny bit before they even hit your eye. And that little bit of spread is just enough to counteract the eye's overfocusing, pushing that focal point right back onto the retina where it belongs. It's so simple, but absolutely brilliant. All right, now let's look at the other side of the coin. We just talked about what happens when the eye is too long, so what do you think happens when it's too short? You guessed it, that's when we get hypermetropia, which most of us just call farsightedness. With hypermetropia, it's the exact opposite problem. The eyeball is a little too short, or maybe the cornea is a bit flatter than it should be. And what this means is that the light isn't being bent enough by the time it gets to the retina. In fact, the theoretical focus point is actually somewhere behind the retina. This is what makes close-up stuff so tough, and it's why your eye muscles have to work overtime just to try and compensate. And all that extra work, that's what leads to that really frustrating eye strain and those nasty headaches. And the fix? Yep, you guessed it. It's the opposite too. We use a convex lens, or what's called a plus lens. This kind of lens does the opposite of the other one. It brings light rays together or converges them. It basically gives the eye that little extra boost of focusing power it's missing, pulling the focal point forward and landing it right on the retina. The result? Clear and much more comfortable vision. You know, seeing them side by side like this really makes it all click, doesn't it? It's just a perfect set of opposites. One is caused by an eye that's too long, the other by an eye that's too short. One focuses light in front of the retina, the other focuses it behind. And of course, their solutions, the minus and plus lenses, are perfect opposites too. But you know, these errors of refraction aren't just about whether the focus point is too far forward or too far back. Sometimes the problem is more about the quality and the flexibility of your focus. And that brings us to two other really common conditions, astigmatism and presbyopia. Okay, so these two are fundamentally different from each other. Astigmatism, that's all about the shape of your eye. Instead of a perfectly round cornea, it's shaped more like a football or a rugby ball. And because of that irregular shape, light ends up having multiple focus points instead of just one. That's what causes that stretched or distorted vision. Now, presbyopia is totally different. It's an issue of age. As we get older, usually starting around age 40, the lens inside our eye just starts to lose its flexibility. It can't change shape as easily to focus on things up close. And this is basically the reason so many of us end up needing reading glasses. All right, after all that talk about the problems, let's get to the really good news. We live in an absolutely amazing time for vision correction. The solutions we have today are more advanced and more accessible than they have ever been. So how do we actually fix these different errors? Think of the solutions like a spectrum of options. It usually starts with eyeglasses, right? That's the classic, reliable fix. Then you've got contact lenses, which are fantastic for people who want a wider field of view. And they even have specialized ones for things like astigmatism.
If you're looking for something more permanent, you can look into refractive surgery, procedures like LASIK that actually reshape the cornea. And for very high prescriptions or unique cases, there are even advanced options like implantable lenses. The bottom line here is, there is almost certainly a solution out there for you.
So, if there's one single thing I want you to take away from all of this, it's this simple truth. Blurry vision is not a weakness. It's not some personal failing. It is, quite simply, a matter of physics. It's just a mismatch between the shape of your eye and the light it's trying to focus. And you know what the best part about a physics problem is? It has a physics solution. With the right correction, your world can be razor sharp again. I mean, think about it. Seeing the incredible details on a leaf, the expressions on people's faces across the room, the crisp, clean letters on a page, all of that can come right back into focus. So it really just leaves us with one final important question to think about. When was your last eye exam?